First, when we introduced it, we talked about two things. Where we talked that CRO can be used to measure voltage, current, phase. So here it tells what kind of things we can do. Actually, whenever some experiments in second semester and third semester, you may have used some use CRO to users to measure some of things. So here you see a lot more things which you haven't done, but there are few things you have already calculated, like voltage and frequency, amplitude, current, phase, resistance, delay, and impedance. These are the things that can be measured with CRO. CRO is used to determine signal origin, modulation characteristics, SSB modulation. These are different things you will get to know more about what it is, but these are the things which can be measured with CRO. CRO is used in television, radar, fault testing of winding in electrical machines. CRO is used to study lithography figures, waveforms, hysteresis loop for magnetic materials, electronic devices phenomena, performance of various states in electronic systems. So it is like a list of different application of CRO. So like there are few things which you have already used. This thing hysteresis loop for magnetic material. So you have done that experiment and traced it. So okay, you may not remember it how it was tuned for that, but when we are seeing the list of applications where CRO is used, it comes something which is familiar to you. You have done it sometimes. So I like other things, the voltage, frequency, amplitude. These things are also quite easy, and you have done it somehow in some of the experiments in second semester or third semester. So now you see this is the screen. You used to have you must have seen it before in some of the experiments. So you see screen is divided in different blocks, horizontal and vertical lines. So from that you can see a signal and so how to, if you want to measure voltage, so you see this peak to peak voltage. So you know what is this position, this wave is there, what is its peak to peak, means from lower peak to higher peak to take, and then you can tell how many blocks it is covering, and then you can by when there are many knobs where we control to see the signal. When we see the signal, there you can calculate that one block. One block means how many volts. So if you know the signal, this is the signal where you can see this is two blocks, and this is one block is further divided into five columns, five different small lines are there. You see, this is the line where you see a lot of small divisions. So this is some big division like these blocks we can see, and then this further block is divided into five. So this is a scale. From this scale, we can tell what is peak to peak distance. So this distance we will have in terms of and this is screen size, and we know the way how to convert it this, into voltage. So एक ब्लॉक का मतलब कितना है, वो जो हम लोग नॉब से सेट करते हैं वहां पे देख के पता चल जाता है, उसका एक फैक्टर हमको मिल जाता है. So if we know the factor, if we know how to convert it, then we will able to tell how it is peak to peak voltage. for this particular signal what we see on the screen. So this is on this axis, vertical. And then what is on horizontal axis? We talked about this time. If we go to this thing, you see this is time based. This is the screen which we see zoomed in that picture. So time based. This thing makes it like when we see on the x-axis. This is the peak. This is the wave. So you take one complete cycle. Like a wave starts from here, it goes like that, it goes like that. So this after this is a complete waveform. So one complete waveform. So you know how much distance this is covering on the screen. And then from time base, we know the conversion formula. So from that we can calculate time period. And from time period you can calculate frequency. So to get the time period, you need to measure the distance and convert it to time by multiplying it by time based setting. So the time based setting में जो भी factor मिलेगा, उसको हम यहाँ से ये जो time period निकाला है, इसको उसे multiply करेंगे, then we will get time. So this is basically what we measure here is distance, and then we get the conversion factor. कि ये जो distance स्क्रीन पे इतना है, इसका मतलब क्या है? एक्स एक्सिस पे टाइम होता है, तो टाइम के लिए बोले कि दिस डिस्टेंस, इफ यू नो द फैक्टर टू कन्वर्ट, you will be able to know what is the time period for this wave. So if you know the time period, we can tell about frequency. So this is very simple. From an example, what we did, we talked about how we are using CRO as to know voltage, to measure voltage, to measure frequency. So these are two things, voltage and frequency. We measure using CRO if there is any signal, and we stabilize it on the screen. It looks like this. So earlier in the starting, we may don't have this this much sharp signal and such stable. Generally, when we give signal, it is not in this form. So we have to tune it using controls we have. So we control it, we make it like that, and then we measure these distances. That is how we use trace in experiments. So generally, when we trace, we need to have a scale associated. Then only from the trace we can tell about this. But since we need to have something in the card, so we generally trace it to keep it in the card to just show its waveform. So sometimes we don't make a scale on the trace paper, but to make such measurement like voltage and frequency and all of that, we need to have a scale associated with that, so that we can claim this is this much distance. And then from setting, we know the conversion factor, so that when we are doing peak to peak voltage on this axis vertical, ये कितना है, तो ये उसका peak to peak voltage होता है. एम्पलीट्यूड जैसे हमको पता करना है इसका, तो एम्पलीट्यूड मीन्स जो भी ये सेंट्रल लाइन है वहां से कितना पीक जा रहा है, that tells amplitude of this signal. So like from that simple picture, we can talk about how we calculate frequency, how we calculate peak to peak voltage, how we can measure the amplitude of this wave, the signal. So these are very basic things, and if you need to measure it, you need a CRO. So CRO, what it does, it visualizes the signal. So what signal is given, we can see it on the screen, and by looking at the screen, we can measure a lot of things about the signal. So without CRO, it was difficult. So this is the role CRO plays. Now you see, this is This is another means we don't have this kind of in our lab. We probably in our lab this is the model we have. And this is a picture where we have a updated model, a different model we can say. So here again it shows same thing. So displaying a voltage waveform. So this is a signal. So it's like that. And here again we can measure voltage, peak to peak voltage, and we know the central line, and we know how much distance is covered from peak to peak. And then we have the conversion factor, and then we can do that. So it is like channel A, channel B, channel C, channel D. This is more of data where we can give four signals at the same time. So they are different instruments. So by looking at it, we will be able to know more about. Like if you remember, once we have went to workshop for some experiments in third semester. So there they have a different kind of CRO. So it doesn't have that CRT kind of thing like this a big cone type of structure in back. Those updated CRO, they are known with some other name probably, but they do the same thing. They have updated technology for that. So now before we have seen these pictures, now you see different kind of signals we may have, like a sine wave. What we are seeing, that was sine wave. Signals can be different types. This is square wave, this is triangular wave. But the concept of this time period and peak to peak voltage remains same, whatever shape of the this signal is. So these things matter for the understanding the nature of signal. Like this is sinusoidal wave voltage, this is angular voltage, this is square voltage. So how to get this kind of signal? This is a different story. But whatever kind of signal we have, if we see it on the screen, we can measure it voltage. We can measure its frequency. For voltage, we see this peak to peak on this vertical axis, or if you say it is x-axis, this is y-axis, so you can say this is y-axis. And for time period, we see on the x-axis. This is complete wave, one complete wave. From that, we know time, and from time period, we can tell about frequency. So set the time based to suitable frequency so that we can see the signal properly in the screen, and then apply the input to Y plate and a steady waveform of input will be displayed on the CR. So this different kind of waveform we can see, different kind of signals we can see on the screen, and where we can be used to measure both DC and AC voltage. So DC voltage, for DC voltage, what we will have a simple line on the screen. So like this is for AC voltage, when we have a sine wave. For DC voltage, we will have a line. So there is a constant voltage given for a reference. So if we given DC voltage, so it will show a line somewhere. So from that we can measure what is the position of line. And then how we measure frequency. We have discussed it, but you see this is that knob what we are talking about, time base. So if we go back to this picture, you see this is time base. So we learn how to measure voltage. Now when we are talking about measure frequency, so this is the time base knob. So it controls it on x-axis when we measure time. It controls this part. So you see, this is time per division. It is. So by just looking this, the kind of conversion factor I was telling कि इसमें हम लोग distance देखेंगे और उसको कैसे convert करेंगे. So you see, on this knob it is very clear. So here is MS. MS means millisecond. So it is the knob is at 2. So we can say एक division means 2 ms. 2 millisecond means 1 division. So we measure this like this. This is the distance. When we measure on the screen, this will be a distance. But we know on this axis this is time. So how to convert into time? We know this is the conversion factor from this time now. First we set it, tune it, then we see where it is, and then we multiply that distance on the screen to this factor, this time knob factor, and then we get time, and from time we can calculate frequency. Frequency means 1 upon time period. So the time per division dial and the oscilloscope control the amount of time per centimeter division on the screen. The simple method of determining the frequency of signal is to estimate its periodic time from trace on the screen of CRT. Just हम लोग जो trace करते थे. To calculate frequency of an observed signal, one has to measure the period, that is time taken for one complete cycle, using the calibrated shape scale. The period could be calculated by a time of number of square centimeters, and then this is the conversion factor what we are talking about. So the position of knob means selected time per centimeter square. So we know this. Once time period is known, the frequency is given by 1 upon c. So the frequency, when if we are given a CRO, and you can tune it to this form, and you can look at the different knobs to know the voltage gain and time-based control. So this is very easy thing, and we have done it quite a few times, some experiments. And now we are moving to next thing, next application. Like we have discussed about voltage, frequency, amplitude, how we can measure it for a particular signal. Now, how we measure phase. For phase, we generally what we do, we have two signals, and we see what is the phase lag, phase difference between these two signals. So how we can do that? So I told that there are two channels, channel 1, channel 2, where we can give two signals, and those both signals will be visible on the screen. And we have seen one CRO where there are four channels. So depending upon channels, how many signals we can give for measuring a phase shift, we need to have at least two signals. So then we can talk about what is the difference between them. So that's so for measurement of phase, we give two signals and then look into that, so that we can, when we see both signals on the screen, then there is a method to calculate phase shift between them, and we can do it using CRO. After learning how we measure voltage, frequency, now we are trying to go to a third step of this instrument, third application of this instrument, about measurement of phase. The calibrated time scales can be used to calculate phase shift between two sinusoidal signals of the same frequency. There are two signals, the frequency same है, so हम उनका phase shift calculate कर सकते हैं. If a dual trace or beam CRO is available, we have two channels to give the signal. Available to display two signals simultaneously. Both of the signals will appear in proper time perspective. So one thing is there, if we do two signals, this time base remains common. So this part, whenever we give, like if we go to this, so this is common. For channel 1, we have this segment. For channel 2, we have this segment. These both are same. If we apply one one signal, then we use this one. We don't use this one. If we have two signals, then we use both. So this is for Y gain, and for time is the x-axis, and Y, this is common for both signals. So this is one thing. So when we give it two signals, this Y gain can be changed, and Y-axis it can have a bigger amplitude, a lesser amplitude. We can tune it from here. This amplification is in our control. But on the x-axis, what happens? This is a constant. This is same for both. So the frequency, if we have some frequency, it has some time period that will be visible for both signals here on the same footing. So if there is any phase difference, it can be seen actually. Like if you see, this is one signal. In if we have one more signal, two channels, so we will have a different wave like that. So if I have a 90-degree phase difference, so what we'll have, when it goes down, that will go up. So it will go like this. So then we can say this has some phase difference, 90-degree, 180-degree. What kind of phase difference? That can be seen even by looking in the screen only. And now we are trying to learn what are different methods to do that. So this is the formula to calculate phase difference between the phase angle theta, phase shift in centimeter. So like when we see on the screen, this is an, and there is another wave. So from that wave, we can mark what is the difference between phase difference between these two waves, and that we will get in centimeter. Like if you have some wave where it gets peak here, and the other wave it gets peak somewhere here. So this will be the distance on the screen in centimeters, the difference in phase. So that is what it calls about this phase. So one phase shift in centimeter and one period in centimeter. So one period कितना है? फ्रीक्वेंसी दोनों का हम लोग बोल रहे हैं सेम है. Sinusoidal of same, two sinusoidal waves, same frequency. So period will be same. So we can calculate for a time period for one, and then we can calculate what is the phase shift within in centimeter, and then we put in this formula, multiply with 60 degree, we get what is the phase difference between those two signals. This is one another application of CRO. So you see, this is an example. These are the different waves, but you can see phase shift in centimeter. This is the peak, this is the peak, okay, and one period in centimeter is this much. Then phase shift can be calculated using this formula.